Hey guys, it's Miss Adams, and we're going to look at the last question on this Unit 9 test review. First thing it's telling us to do is to factor. After we factor, we're going to find the x-intercepts from our factored form. Then we're going to find the vertex, and from there we're going to graph this function. So first things first, when I factor a trinomial, so I've been given f of x equals negative 3x squared minus 12x minus 9. Hey guys, before I even go any further, I know it doesn't ask this, but from standard form, we can find our y-intercept. So if I were to find the y-intercept for this, I would say it's at 0, negative 9. Now let's go ahead and factor this fully. So I'm going to divide each of these terms by their greatest common factor, which in this case is a negative 3. Remember, I don't want that leading coefficient to be negative, so my GCF is 3, or negative 3, excuse me. So if I factor out the negative 3, I've got x squared plus 4x plus 3, which is going to give me my new a, b, and c values, and I can create my t-table from here. I've got an a value of 1, so I've got an a value of 1, a b value of 4, and a c value of 3. One times 3 yields the value of 3. And the only factors of 3 are 1 and 3. But in this case, I want them to multiply to be positive and add to be positive now that I've factored out that negative 3. So I know that 1 plus 3 yields a positive 4. So I'm going to break my 4x into 1x plus 3x. And I can bring down my x squared and my positive 3. And now we factor by grouping. My greatest common factor from the first grouping is an x. Greatest common factor from the second grouping is a 3. So that leaves me with x multiplied by x plus 1 plus 3 multiplied by x plus 1. Those are the same thing. So my factored version is that f of x equals negative 3 multiplied by x plus 1 multiplied by x plus 3. Now we want to look at the x-intercepts. So I'm going to look in here. I noticed that my x values, they don't have a coefficient of anything other than 1. So I can just take these numbers that are inside the parentheses and flip their values to give us x-intercepts of negative 1, 0 and negative 3, 0. Now let's find our vertex. First thing I got to use is that axis of symmetry formula. So I've got negative b over 2a. But looking at my function, it doesn't matter if I use the one that I've taken the GCF out of or not, because I've already taken out a common factor there. So it would work either way. But if I go back to the original function, I've got negative 12 divided by 2 times negative 3. So that's going to give me 12 over negative 6. And that gives me an axis of symmetry at negative 2. Guys, I'm going to go ahead and draw that on my graph because I know eventually I'm going to have to graph this function. I'm also going to go ahead and graph my x-intercepts and my y-intercept. So I know I have a y-intercept at 0, negative 9. Excuse me there. And I've got x-intercepts at negative 1, 0 and negative 3, 0. Now, I'm going to finish out my vertex here by saying y equals, and I'm going to go back to my original equation, negative 3 times negative 2 squared minus 12 times negative 2 minus 9. So I'm just going to plug in that negative 2. It's very important that you use the original function here. So I've got negative 3 times negative 2 squared minus 12 times negative 2 minus 9. So the y value of my vertex is a positive 3. So therefore my vertex is negative 2, positive 3. So here's the vertex of my function. Now let's go ahead and plug this function into the table function on the calculator. So I've got negative 3x squared minus 12x minus 9. And I'm starting at negative 4. So my values in this case are negative 4, negative 9, negative 3, 0, negative 2, 3, negative 1, 0, and 0, negative 9. So I've got negative 4, negative 9, and I already have the other 3 graphed. So I'm going to connect the dots, and that will be my graph version of this function. Now we're going to go on to the second function, and you may hear some kids in the background here. I apologize. That was the release of the lunch bell. And the first thing it tells me to do is to factor this function completely. So I've got y equals x squared minus 16. Guys, I've only have a binomial here, and it's got a subtraction symbol in between. So the best place to start is to see if it's a difference of 2 squared. And in this case, it is. I've got x squared, which is x times x. And I've got 16, which is going to be 4 times negative 4. So my factored form here is x plus 4 and x minus 4, leaving me x-intercepts at positive 4, 0 and negative 4, 0. So I know I've got one at negative 4 and at positive 4. I also know that I have a y-intercept at 0, negative 16. So here's my y-intercept. And now we can use our axis of symmetry formula. But guys, if you remember, I did teach you a little trick here. When you don't have a b value, your y-intercept should be the same as your vertex, or vice versa, your vertex should be the same as your y-intercept. Well, let's check this. I've got negative b over 2a, where my b value in this case is 0. My a value is 1. So I've now got 0 divided by 2. And 0 divided by 2 is just 0. So x equals 0 over 2. So my axis of symmetry is going to be my y-axis, which is just where x equals 0. And I'm going to plug that back into my function. So I've got y equals 0 squared minus 16, yielding a y value at negative 16, which is what we just confirmed, that my vertex is the same thing as my y-intercept at 0, negative 16. Last thing we're going to do, guys, is put this into the table function. So I've got x squared minus 16, and I'm starting at the value of negative 4. So when I start at negative 4, the rest of my function is negative 4, 0, negative 2, negative 12, 0, negative 16, 2, negative 12, and 4, 0. So I've got negative 2, negative 12, 0, negative 16, and then 2, negative 12. Connect the dots, and there's our parabola. All right, guys, good luck. I love you. Do well.